Blockchains are extremely popular today, but what exactly is a blockchain? How does it function? What issues does it address? And how can it be utilized? As the name suggests, a blockchain is a sequence of blocks that store information. This concept was first introduced in 1991 by a group of researchers with the goal of time-stamping digital documents to prevent backdating or tampering, similar to a notary. However, the idea remained largely unused until Satoshi Nakamoto adapted it in 2009 to develop the cryptocurrency Bitcoin. A blockchain is a decentralized ledger that is accessible to everyone. One of its key features is that once data has been added to the blockchain, altering it becomes extremely difficult. But how does this work? Let's examine a block in detail. Each block consists of three main components: stored data, the block's hash, and the hash of the preceding block. The type of data inside a block depends on the blockchain it belongs to. For instance, the Bitcoin blockchain holds transaction details, including the sender, recipient, and the amount transferred. Every block also has a unique identifier called a hash, which functions similarly to a fingerprint. It uniquely identifies the block and its contents. Once a block is generated, its hash is computed, and if any data within the block is modified, the hash will change accordingly. This makes hashes a crucial tool for detecting alterations. If a block's hash changes, it is no longer considered the same block. The third component in each block is the hash of the previous block, effectively linking blocks together to form a secure chain. Let's consider an example. In a chain of 3 blocks, each block contains its own hash and the hash of the preceding block. Block 3 points to block 2, and block 2 points to block 1. The first block is unique since it has no predecessor. This is called the genesis block. Now, if someone modifies block 2, its hash will change, making block 3 and all subsequent blocks invalid, as they will no longer reference a valid previous hash. However, hashes alone are not enough to prevent tampering. Modern computers can compute thousands of hashes per second, making it theoretically possible to alter a block and then recalculate all subsequent hashes to maintain a valid chain. To counter this, blockchains incorporate a mechanism called proof of work, which deliberately slows down block creation. In Bitcoin's case, computing the required proof of work takes approximately 10 minutes per block. This delay makes tampering much harder, as altering a single block would require recalculating proof of work for all following blocks. Blockchain security is strengthened through hashing, proof of work, and decentralization. Instead of relying on a central authority, blockchains operate on a peer-to-peer network that anyone can join. When a new participant connects, they receive a full copy of the blockchain, allowing them to verify its integrity. Whenever a new block is created, it is distributed across the network. Each node validates the block to ensure it hasn't been altered. If everything checks out, nodes add the block to their own copies of the blockchain. The network collectively establishes consensus, agreeing on which blocks are legitimate. Any block that has been tampered with is rejected by the other nodes. To successfully manipulate a blockchain, an attacker would need to alter every block, redo the proof of work for each one, and gain control of over 50% of the peer-to-peer network. This is nearly impossible. Blockchains continue to evolve, and one of the latest innovations is smart contracts. These are simple programs stored on the blockchain that automatically execute transactions when predefined conditions are met. More on smart contracts will be covered in a future video. The rise of blockchain technology has captured widespread interest. People soon recognized its potential beyond cryptocurrencies, applying it to areas such as secure medical record storage, digital notarization, and even tax collection. Now you have a fundamental understanding of what a blockchain is, how it operates, and the problems it solves. As always, thank you for watching.